Hi everyone. Today we're going to focus on HTTP 1.1 and we'll see what are the improvements it brought on top of HTTP 1.0 and what are the issues it had. So despite it being released in 1997, it is very important as it is still in being used today. So whenever your server or clients do not support HTTP 2 or HTTP 3, they fall back to HTTP 1.1 version. Okay, so one of the major improvements HTTP 1.1 brought on top of HTTP 1.0 was the introduction of persistent TCP connections. So as you would know, HTTP 1.0 and HTTP 1.0, we always needed a separate TCP connection for a separate request, but here the TCP connections were persistent. So let's say whenever a client makes a request, let's say you have a client and you have a server. So whenever a client tries to make a request to the server on HTTP 1.1, it will open a TCP connection. So a three-way handshake will happen on this TCP connection, and a TCP connection opens. Now, now what happens is a request is sent from the client, and the response is received from the server. Now, once the request and the response loop is done, this connection is not closed based on your client settings. That is your keep alive that was introduced in HTTP 1.1. So let's say if the keep alive is 5 minutes, the next 5 minutes, this TCP connection will not be closed and it will be open to be sent and receive data to and fro. So what happens is this enabled pipelining in HTTP 1.1. Okay, now what is pipelining? So in pipelining, let's say one of the request is sent. So let's say request 1 was sent and response 1 was received. So what happens is, let's say if client wants to send multiple requests at the same time, okay, they can send. So without waiting for the response. So let's say request 1 was sent, response 1 was received. Now request 2 is sent, and request 2, let's say at the server's end, is taking some time for the response to be generated. So what the client can do, it need not wait for the response of request 2, it can send request 3 as well, and it can also send request 4. So multiple requests can be sent one after the other without waiting for the consecutive response of the previous request. Okay, so this was pipelining. Okay, and then it would send the response back. The server would send the response back one after the other. Okay, so pipelining was enabled because you had persistent connection. So same TCP connection could be used for the same server and client. Now it enabled host header. So as we discussed in the last video, let's say you have a client and the client makes a call to a domain name, let's say google.com, and the google.com resolves to makes a DNS resolution, and it resolves to a public IP. This public IP is basically an IP of the server. Okay, let's assume destination server. Now on this server, let's say we have google.com hosted, and on this server we have multiple other websites hosted as well, like Facebook and Instagram, let's say. So what would happen is, since the host headers were mandatory, okay, so on every request that is leaving the client, request 1, request 2, there are multiple tabs, let's say, open at the client. Let's say the same client, the same browser is having multiple tabs open, and on each tab you are accessing, on one you are accessing Google, on the other you are accessing Facebook. So every request will have a host name. So what is the host it's trying to access? Every request will contain the host details. And once the request falls on this gateway public IP, this request will be basically routed to its corresponding host. So let's say if here the host is Google, it will be routed to Google. If the request here is host here is Facebook, it will be routed to Facebook. So this enabled basically virtual hosting. So now your IPv4 addresses were more were used in a better way, because multiple resources could actually share your IPv4 address, that is your public IP. Okay, so this was one of the important items of HTTP 1.1. It enabled host headers. Also, it enabled chunk transfer encoding. So in chunk transfer encoding, as we discussed again in the last video, let's say client makes a request to the server, and the server basically this response is basically a bigger response, and the server has to generate the response. So partially the server can keep sending the chunked responses on the TCP connection, on the same TCP connection, one by one, and it will just type in the headers that the response type is chunked, and then it will keep on sending the chunked response. It need not tell the whole length of the response as content length in the metadata headers of the HTTP all at once. It can keep on generating the responses and keep sending on the TCP connection, and the client will know that, okay, since the type is chunked, so basically I will keep on receiving the data unless and a final end of file is received. Okay, so this was about chunk transfer encoding. So this was like this enabled better throughput because your data could be sent while your partial data could be sent while your server was working to generate more and more data. So this made streaming very easy, and you as the streaming was is very important for live events. So whenever you are watching any live events on your browser, probably it could be using HTTP 1.1. Because of HTTP 1.1 it was made possible because of chunk transfer encoding. Now it had better cache mechanisms. We saw in earlier video that HTTP 1.0 lagged when it came to caching because it could not differentiate between a public cache and a private cache. Now it in HTTP 1.1 basically public cache and private cache were differentiated. So whenever a cache was marked as private, it was only cached at the client's end, or the application running at the client's end, whether it is your browser or your phone application. It was only cached at the client's end. And whenever it was marked as public, whenever any information was marked as public, it could be cached at any intermediate servers as well, whether it's your ISP, internet service provider, or your CDNs. Okay, also it all provided a max age of the cache. Rather than providing a timestamp, it provided a max age. So let's say if the max age is 3600 seconds, so basically for 60 minutes you could cache this particular request. So for each of the servers the time would start, it was agnostic of the timestamp. So let's say if here it is around, if here the timing is 6 a.m. GMT, it would cache till next 60 minutes. If here the timing is 5 a.m. GMT, it would cache for next 60 minutes, irrespective of whichever time zone it falls into. Okay, so it had better caching mechanisms, and obviously it added more HTTP methods like put, delete, and options in. So this basically encouraged your your REST infrastructure. CRUD is basically a create, read, update, and delete. So your REST architecture basically was your REST architecture works on HTTP 1.1, wherein your basically it's basically called a representational state transfer. The APIs contracts that we have, each API contract is each item is taken as a resource. Okay, and this architecture was facilitated because it had all these methods like put, delete, options, etc, etc. So REST architecture on HTTP 1.1 was enabled because more methods were added on HTTP 1.1. Okay, now coming to the issues of HTTP 1.1, this is important. So a head of line blocking was introduced in HTTP 1.1. Why would I say introduced? Because you enabled persistent TCP connection. So as a part of persistent TCP connection, you had pipelining, right? Multiple requests were shared simultaneously. Okay, now what happens is when the server tries to send the response, it has to send the response of the first request first. Okay, so let's say if the request 2 was made first, although it has generated the response of request 4, it cannot send the response of request 4. First it has to send the response 1, response 2, then response 3, and then response 4. Even if, let's say, your response 4 was generated first, it had to wait because your response 2 has not yet been generated or given back. So it was like head of line blocking because the request that came in first, since we have not replied to that, we will not reply to the other requests that came in later, although I have the response already generated. So this was like head of line blocking. Now, uh, because so the clients, what it did was, to get away from head of line blocking, it basically opened too many TCP connections. So let's say we have a client and a server, and let's say we have only one TCP connection, and let's say it makes parallelly three requests, request 1, request 2, request 3, and request 4. And let's say request 4 is basically taking the most amount of time. So all these request 1 is taking the most amount of time, so all these requests will have to wait unless and until the response to request 1 is basically generated. Now to counter to this, what the clients did, it opened multiple TCP connections. So let's say we had connection 1, connection 2, connection 3, and let's say the request of these four requests were splitted across. So let's say on one TCP connection it would send request 1, on second it would send request 2, on third it would send request 3 and 4. Now what would happen is, although your request 1 is slow, your since request 2, 3 and 4 are on different TCP connections, it need not matter. It need not matter because they would not wait, because it's a separate TCP connection. So now what is the backdrop of that? Basically, you are again ending up going back to the previous version where you had one connection per request. Because you're opening too many connections, you are going back to the back to HTTP 1.0, where you opened one TCP connection for one request. You are again having multiple TCP connections. You have to manage them. There's a three-way handshake that happens. There's a lower throughput that then again comes in play. So basically all those things were there. Now, there was no multiplexing that was allowed. Now, what is multiplexing? Multiplexing is basically combining of multiple requests in a single transfer media. So here the media is TCP connection. So let's say you have client and a server, and you have one TCP connection. So multiple requests were allowed, but they were allowed sequentially. So once the request 1 is sent, then only I'm able to send request 2, and then only I'm able to send request 3. They were not allowed in parallel. Okay, these requests were not allowed in parallel. Only after request 1 was sent, you could send request 2 or request 3, and only after request 2 was sent, you could send request 3. Okay, you could not send them in parallel. So although they were sequential on the same TCP connection, but they were not parallel. So that's why multiplexing was not achieved as part of HTTP 1.1. Now in the next video, we'll deep down into multiplexing. We'll see how multiplexing works and how HTTP2 achieved that. And for this video, that's it. Thank you.